Hello students, so we have been discussing chapter number 10, that is haloalkane and haloarine. We have discussed so many topics of this chapter like preparation of haloalkane and haloarine. We have discussed nomenclature, right? We have started with nomenclature. Then we have discussed chemical properties of haloalkane and haloarine. We have also discussed SN1 SN2 reaction. Then we have discussed stereochemical aspects of haloalkane. Okay. Today we are going to discuss last topic of this chapter, and the topic is polyhalogen compounds. So today's topic is polyhalogen compounds. Okay. So let us understand the meaning of this topic. Poly. We all know that the meaning of poly. Poly means many, and halogens means halide ion. So it can be fluorine, it can be chlorine, it can be bromine, or it can be iodine. So the meaning of this topic is those compounds which are having many halogen atoms in their structure. Many halogen. Polyhalogen means the compounds which are having many halogen atoms in their structure. Okay. So which are polyhalogen compounds that we are going to study in chapter 10? So first is CH2Cl2. CH2Cl2 is dichloro. Two chlorines are there, that is dichloromethane. Then second compound is CHCl3, that is trichloromethane. This is dichloromethane, this is trichloromethane. One carbon is there, three chlorine atoms are there, so that is trichloromethane. And the common name is chloroform. So this is chloroform. Third compound is CHI3, that is triiodomethane. One carbon is there, so because of that, that is methane. Three iodines are there, so it is known as triiodomethane. The common name is iodoform. Common name of this compound is iodoform. Then fourth compound is CCl4, that is tetrachloromethane. Four chlorines are there and one carbon is there, so that is why it is known as tetrachloromethane. Next compound is Freon. And last compound in our syllabus is DDT. DDT. We all have heard about DDT. Dichloro, diphenyl, trichloroethane. The full form of DDT is dichloro, diphenyl, trichloroethane. So these are the polyhalogen compounds that we are going to study in this topic. Okay. Now this topic is basically theoretical topic. So we need to remember many things, right? This is theoretical based topic, or we can say memory based topic. So this topic is memory based, so because of that we are going to study this topic in animation. So animation will be there, so we are going to study this topic by animation. Okay.
Polyhalogen compounds are carbon compounds containing more than one halogen atom. Some examples of polyhalogen compounds are shown here. Many polyhalogen compounds are useful in the industry and in agriculture. Dichloromethane, also called methylene chloride, is a colorless volatile liquid with a moderately sweet aroma. Dichloromethane is used as a propellant in aerosols and also as a paint remover. However, the use of dichloromethane for removing paint has been banned by the European Union since it is a carcinogen or a cancer-causing agent. Dichloromethane is also used as a process solvent in the manufacture of drugs. It has additional uses as a metal cleaning and finishing solvent. There are some very real human health risks associated with exposure to dichloromethane. It harms the central nervous system. Exposure to even low levels in the air can lead to slightly impaired hearing and vision. Exposure to higher levels in the air may cause dizziness, nausea, and tingling or numbness in the fingers and toes. The skin may experience an intense burning sensation and mild redness if it comes in direct contact with dichloromethane. If dichloromethane comes in direct contact with the eyes, it may burn the cornea. Trichloromethane, or chloroform, is a colorless, volatile, non-flammable liquid with a sweet odor. It is used as a solvent for fats, alkaloids, iodine, and other substances. It is also used in the synthesis of Freon, a refrigerant, or R22 shown here. Many nations are phasing out the use of R22 due to concerns about its role in ozone depletion. Chloroform was once used as a general anesthetic in surgery. However, this use has been discontinued as there are a number of safer alternatives. Exposure to chloroform can cause serious problems to human health. Breathing in chloroform vapors depresses the central nervous system. Not surprising, considering its historical role in anesthesia. Breathing chloroform about 900 parts per million, even for a short time, can cause dizziness, fatigue, and headache. Chronic chloroform exposure may cause damage to the kidneys and liver. In the liver, chloroform is metabolized to form phosgene, a deadly gas. We'll discuss phosgene in greater detail shortly. Some people will develop sores if the skin comes in contact with chloroform. Chloroform is slowly oxidized by air in the presence of light into deadly phosgene gas, as shown in the reaction. Therefore, chloroform is stored in dark bottles to prevent exposure to light. The bottles are filled completely to keep air out. For the sake of safety, handle every bottle of chloroform as if it contains phosgene. Wear gloves and eye protection. There are simple tests that you can carry out to determine the presence of phosgene. Phosgene, or carbonyl chloride, has a characteristic odor of cut hay. It is highly toxic. In fact, it was used as a chemical warfare agent during the First World War. If you detect the odor of freshly cut hay when working with chloroform, you should seek medical attention. Chloroform contaminated by phosgene should not be used and should be properly disposed of as chemical waste. Triiodomethane, or iodoform, is a pale yellow crystalline solid. This volatile compound has a pungent, medicine-like odor. Iodoform has uses as an antiseptic. Gauze packing with iodoform is used in medical applications. However, the antiseptic properties are due to the liberation of free iodine, not the triiodomethane molecule itself. Due to iodoform's penetrating odor, other antiseptics are used more commonly. Carbon tetrachloride, or tetrachloromethane, is a clear liquid with a sweet smell. Carbon tetrachloride has a variety of uses, including in the manufacture of refrigerants and aerosol propellants. It is used in the synthesis of chlorofluorocarbons. It is widely used as a solvent. Due to safety concerns, many chemists prefer to use other solvents. In the past, carbon tetrachloride was used as a dry cleaning fluid, a degreasing agent and spot remover, and also as a fire extinguisher. These uses have been generally phased out to minimize health risks. The health risks associated with carbon tetrachloride are very serious, as the substance is a suspected carcinogen. Chronic exposure to carbon tetrachloride may cause liver cancer in humans. Kidney damage is also a risk. The side effects of exposure to carbon tetrachloride include dizziness, lightheadedness, nausea, and vomiting. It causes eye irritation and may lead to an irregular or stopped heartbeat. Continued exposure can lead to unconsciousness, coma, or even death. Carbon tetrachloride has been linked to the depletion of the ozone layer. Depletion of the ozone layer increases our exposure to ultraviolet light, leading to a higher risk of skin cancer, eye diseases, and disorders, and possible disruption of the immune system. Freon is the name given to a class of compounds that are chlorofluorocarbon derivatives of methane and ethane. These compounds are extremely stable and unreactive. They are non-toxic, non-corrosive, and easily liquefiable gases. Freon 12, illustrated here, was one of the most commonly used freons in the industry. It is manufactured from carbon tetrachloride by the Schwarz reaction. Former uses of Freon 12 included aerosol propellants, refrigeration, and air conditioning. Since 1994, the use of Freon 12 is being phased out according to the Montreal Protocol due to environmental concerns. Freon 12 and other chlorofluorocarbons are known to initiate radical chain reactions that lead to the destruction of the ozone layer. The final compound that we'll discuss is known as DDT. Paul Mueller was awarded the Nobel Prize in Physiology and Medicine in 1948 for his discovery that DDT could be used as an insecticide. DDT has been used to prevent insect-transmitted human diseases such as malaria, spread by mosquitoes, and typhus, spread by lice. However, many insect species develop resistance to DDT, limiting its effectiveness. DDT is toxic to many species of fish. For certain species of birds, such as ospreys, eagles, pelicans, falcons, and hawks, DDT exposure leads to thinning of eggshells, causing serious population declines. DDT is stored in the fatty tissue of the body and is metabolized very slowly. As a result, it persists in animals and becomes more concentrated in species higher in the food chain. The use of DDT in agriculture has led to measurable DDT levels in humans. The use of DDT was banned in the United States in 1973. However, it is still in use in some parts of the world.